All right, so let's go ahead and jump back in here to chapter 6. This chapter itself is going to cover files and exceptions. So up to this point, we've been using a lot of keyboard input, a lot of console output. And while those are very, very useful, especially for sort of user interactions, it's extremely important to understand how files sort of work with these programs that we're using. Because if you want to have any data that's permanent, if you want to do anything that will be retained after your program runs, you got to be able to save that to some sort of a format, save that to somewhere that is non-volatile. As we mentioned in chapter 1, obviously that RAM is volatile, and the program itself is loaded in from the disk to the RAM while it's executing. So the data that it's processing and everything that it's using is there on RAM, but once that program closes down, that area of RAM is freed up and you lose all the information. So it's extremely important to be able to, besides printing it out to the screen or taking it in from the computer, save that somewhere, right? Otherwise, it's kind of useless to be able to have a program that can't really have anything that is persistent, is how we call it. Persistence means that it continues even after the program runs. Okay, so we're going to be covering files and exceptions. Now, again, it may seem like they're a little bit different from each other. Files basically deals with I/O. Exceptions, though, are a way that you can manage the flow and the the flow and the operation of your program by catching any errors that may exist. Okay. So in this chapter, we're going to be covering, obviously, file I/O, loops to process files. We're going to be covering processing records as well, and you'll see what that is when we get to that point. And then, of course, we're going to be talking about those exceptions as well. All right, so we're going to introduce you here to file I/O. As you've noticed thus far, the input that we've used is strictly keyboard. Okay, so we've been using the input function, which returns a string. It takes in a string, and that function will allow the program to interact with a user. So you can throw out the input function call, and you could take input from the keyboard, which is useful, but sometimes it might be nice if you could actually bring some data in off of the system that you're using. Let's say it's in the file system somewhere. There's a record, a CSV, an Excel spreadsheet, something like that you would like to bring that data in and make that a part of your program flow. So to be able to do that, you need to be able to open up files from your file system. Same thing goes with file output. So there may be a situation where you're taking user input, or you're making measurements, or you're calculating some sort of an equation. You can actually write that out to a file as well. And usually file input, file output sort of go hand in hand. Generally, you're going to open a file, you're going to do some processing, you're going to write something to a file, and then you're going to close the program down. So again, for a program to retain data between the times it's run, you have to save that data to some sort of a medium. In general, on a computer, it's saved to a file. Okay, so data is saved to a file, typically on a computer disk. That's going to be saved to your secondary memory. Again, we remember that primary memory is your RAM, and your secondary memory is your SDD or your HDD, your solid state drive, or your hard disk drive. And again, what's cool about that is once you save that off to a file somewhere, it can be retrieved for later use, right? You can have a computer program that writes information to a file, and then it pulls that information back in. And cool thing is you can have multiple different files. So you may have a program that you write where you have some things that you need to set, maybe some constant variables or something like that. That would be nice to be able to change. Well, you can write those constants into some configuration file that you can have easy access to. And then when that program boots up, you can have it just read off those variables into the program, and you already have the program configured the way you want it to be. And then at that point, you can start writing to CSVs, you can start writing all kinds of different stuff. So again, writing data to, as this is sort of the common verbiage that we use, writing data to simply means we're saving data into a file. Okay, and then again, a little bit of a definition. The output file obviously is the file the data is written to. So if my program is going to write this file to dictionary.txt, that is the output file. So essentially, when I write to dictionary.txt, I am saving data to the output file, which is the dictionary.txt. All right, so a little bit about these secondary memory drives. Obviously, here we have a hard disk drive platter sort of visualized here for us. Obviously, if it's an SDD, it's going to be a little bit different. But this is kind of nice because you can sort of see how the sectors and all the little chunks and pieces work together. So again, here's file input, right? So we're writing data to a file. So you have this little platter, it's sort of circular. And what ends up happening is in your program, you have a variable called pay rate. okay, and that's 1865 in this case. And then you have a variable called employee ID, and that's 7451Z in this case, and then an employee name, okay? So you've taken this input, let's say it's some sort of an HR software, and it would really be nice, since you've added this new employee, to be able to save that for a later time. So what you can do is you can actually write these two chunks on the memory here, okay? So again, this one, I guess in particular, is a file, as they're sort of calling it. And we're going to talk about file objects here in a little bit. But this is the data in the file. Okay, so again, this is writing data to a file. So you can imagine this is your program, and you're pushing data out onto that secondary drive. So go in the opposite direction, so we can write data to an output file. We can also read data in from an input file. So reading data is the process of retrieving data from a file. And again, that input file is a file from which data is read. Now, there's kind of a general algorithm that we follow in terms of reading data in. We want to open the file, which means we get the file accessible to our program. Then we want to sort of loop through that file, or we want to process that file in some way. And then we always close the file. And I always have my students get this in their head. For every open, there is a close. For every open, there is a close. For every open, there is a close. Okay, so as we're going through these exercises, I want you to always remember in your head, for every open, every time you open a file, you must close it. Now, the reason why this is extremely important is when we open the file, we pull the contents into RAM, and then we modify the contents. And then once we're ready to actually write the contents, we write it to the file, but we don't finalize the writing to the file until we close the file. So what will happen is if you don't close the file may or may not have the data that you just saved in. So you'll always want to make sure that you close the file after you open. Now, there are some shortcuts to do that, which I'll show you later. But for now, just remember, for every open, there must be a close. So again, here's the other direction. When I open a file, I make this data available, and I can read that back into some sort of a variable. All right, so here's sort of a general overview on what files are. You know, I think everybody has a general understanding of what files are. I mean, we all have computers. We've used text files and Microsoft document files, and we've seen JPEGs and PNGs, and we've seen MP3s. And so nowadays, it's a pretty familiar concept, but we're going to kind of dive in a little bit deeper just to make sure we don't have any holes in that foundation. So in general, with what we are going to be working with here in Python, we can work with any type of a file, but to start with, we're going to be working with text files, and then we're also probably going to be working with CSVs. Now, it's important to remember, we can work with any file, okay? And we can actually treat any file as anything. So we could actually have a JPEG file sitting on our hard drive that we can open into Python, and we can actually treat that like a text file if we want to. Now, most of the stuff that comes out of that JPEG is going to be just hexadecimal garbage, but it's important to understand that the way that the computer sees that is it's just zeros and ones. Okay, so there's really no difference in the program between a JPEG and a TXT. It's just how we treat that data that matters, because it's just all zeros and ones. So the first of the two types that we're going to be messing with a little bit, and mostly we're going to be messing with the text file, is the text file, and that contains data that's been encoded as text. As we mentioned in Chapter 1, we have ASCII encoding, right? So we use this ASCII table to convert binary to characters, to convert characters to binary. So generally, a text file is going to be encoded in ASCII. And so all those zeros and ones are going to be saved to the disk, and then when it's read back, it's going to be sort of filtered through that ASCII table and turned back into characters and spaces and special characters. Now, we also have binary files. Now, if we really want to get specific, a text file is a binary file, right? Because the text file is saved as zeros and ones. Every file is a binary file, right? But the difference that we're going to say between the binary file and the text file actually is sort of encoded using ASCII, and then it can be decoded using ASCII. So the zeros and ones can be turned into character data, right? This binary file, on the other hand, has no encoding. It just contains data that's not been converted to text, right? It's just zeros and ones. And honestly, we can write any file to a binary file, and we could write any file to any file format, right? So I could actually write a text file, I could save it as a JPEG, and I could send that quote unquote image to whoever I want to. Now that's, interestingly enough, how a lot of malware is delivered. It's all zeros and ones, so it doesn't really matter what extension you give it. So you can actually, and how a lot of illegal content is covered up by simply changing the extension. So a lot of investigations in cybersecurity actually will go through and look for hints inside of the binary for what kind of data actually lies in that, because there are headers and there are footers and JPEGs and PDFs and Microsoft documents that we can tell what kind of a file that is. So it's not a very good way to cover up data, but it is a way that is used. So again, every single file that we have is a binary file, but a text file has generally ASCII encoded data on it. Okay, so again, there's two ways to access the information in those files. And the way that we're generally going to be doing it is the first way, and it's sequential access. Okay, so you file read sequentially from the beginning to the end. You don't skip ahead. Okay, that's sequential access. So let's say I have a text file that is I love dogs, I love cats, because I don't know who's dog people and who's cats people here, but I love dogs and I love cats. Okay, so I can open that up and I start at I, and I read out the line that says I love dogs, and then I go to the next line and it says I love cats, and then it's done. Okay, so I've read from the beginning to the end. I don't open it up and immediately go to I love cats. Okay, so we're reading sequentially from the beginning of the file to the end. All right, now there's also direct access, which means you can jump directly to any piece of data in the file. We are not going to be messing around with that with this semester because it's very complicated to set up, but it is a possibility. So again, as I mentioned on the slide before, there are things called extensions, okay? And we're very familiar with those. As a society, we're all very digitally in nature. So we know what a JPEG is and an MP3 is, and generally we know what a TXT is and a PDF, right? We're all kind of familiar with this sort of lingo. But these file name extensions in general, they're just sequences of characters that are going to appear at the end of a file name to tell what it is, right? So it indicates what type of data is stored in the file. So, and what's interesting is on a Windows machine, you actually have a Windows registry, and there's an entire portion on that Windows registry that simply aligns extensions like .jpg with some sort of a program that can open, which is, Windows Picture Viewer or whatever that might be. So these extensions are extremely important. What's also cool is these extensions, they're kind of just a superficial representation of what's inside of that file. What that file actually is the contents of that file, right? So if I write something as a PDF and then I just open up my file system, which manages all the files, so Windows Explorer or whatever you use, and then I just right click on it and I say rename and I change the extension to .jpg, that doesn't actually change the file at all. All the contents of the file are exactly the same. All that changes is the extension, okay? So the extension is just a hint. It actually doesn't really define anything. You could really, confuse your operating system, but it doesn't change any of the data on the actual file, okay? So the next thing that we have here, and I mentioned it earlier, is this concept of a file object. Now, a file object is any object associated with a specific file, so it kind of provides a way for a program to work with a file. So it gives us some methods and some little dot notation tricks that we can do to be able to actually read from that file. So some other really smart coders have put together some of these packages so that we don't have to do it manually. All right, so we're actually going to take a little bit of a break. I want you to get a drink, digest a little bit of this information, then we're going to jump on to the next section. We will see you on the other side.